Today we'll talk about section 4.1, angles and radian measure. An angle is formed by two rays that have a common endpoint. So let's say you started with two rays, one on top of the other here. One ray would stay the same while the other would move to create an angle. The common endpoint here, that is the vertex. The side that stays the same, right here, this is what's called the initial side. It is the side that is fixed. It does not move. The terminal side, right here, is the side that rotates to form the angle. So there you have it. The angle is formed by two rays, one staying fixed and the other one rotating to form the angle. An angle is said to be in standard position if A, the vertex, is the origin. So if you draw an XY axis, if the vertex is the origin here, and the initial side is on the positive x-axis, any angle here, let's say we rotate it like that, this angle is said to be in standard position because the initial side here is fixed on the positive x-axis and the vertex is the origin. So if you notice here, remember in a coordinate plane we have four quadrants. We have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now, positive angles is when you would rotate an angle counterclockwise, meaning it goes with the quadrants. So for example, if I said this angle was 130 degrees, it is going to be positive 130 because it's rotating with the quadrants. It's rotating counterclockwise. Let's say I rotated it in the other direction. Let's say here's my quadrants. And let's say I have an angle in standard position, but let's say I rotated it this way. And let's say I went there. And let's say it was 120 degrees that I went that way. Except now, because I went in a different direction, I went against the quadrants, I went clockwise, it is said to be negative 120 degrees. So it's negative angles are when you rotate the angle clockwise. Now, in theory, the space is not negative. It's just the negative sign stands for direction only. The negative sign says, okay, I went in the direction of clockwise as opposed to counterclockwise. But the actual measure is not a negative. It's just the fact that the direction you went is negative as opposed to positive. When the terminal side lies in a quadrant, we say the angle lies in that quadrant. So for example, now notice, if you have a coordinate plane, this would be 0 degrees if it just stayed there, the angle. This would be 90 degrees if the angle rotated that far. This would be 180 if the angle rotated. So here would be 90, 180, then another 90 degrees would be 270, and then all the way around the circle would be 360 degrees. So the first positive x-axis is either 0 or 360 depending upon how you rotate it. So if we rotate an angle, let's say we say 125 degrees, so that means it would start here, and it would go 90, and then another, say, 35 degrees. So we know, because it's between 90 and 180, we know that this is in the second quadrant. Because remember, this is the first quadrant, that's the second quadrant. So that's what it means when it says the terminal side lies in a quadrant. We say the angle lies in that quadrant. So this 125 degree angle said to lie in the second quadrant. A quadrantal angle is any angle that does not lie in a quadrant but lies on the axis. For example, 90 degrees is considered a quadrantal angle because when you rotate it, 90 degrees will wind up right on the y-axis. It's not in a quadrant, so therefore is what's called a quadrantal angle, meaning it basically ends on either the x or y axis. If you kept going, like 180 degrees would be a quadrantal angle because it lies on the x-axis. So measuring angles using degrees. Well, one circle equals 360 degrees, as we just talked about. An acute angle is any angle that is between 0 and 90 degrees. And when I say theta, that just means the angle. So any angle between 0 and 90 degrees is an acute angle. Any angle between 90 degrees and 180 degrees, that is obtuse. Any angle that is just 90 degrees is a right angle, and any angle that is 180 degrees is considered a straight angle. So that is how we classify angles using degrees, and you remember that from geometry. Now, the concept of a radian. A radian is basically a different way to measure an angle, and it deals with the arc length. So if you look at this here, this S is considered the arc length. And basically, it's based upon the central angle. So notice if this is the center of the circle, let's say it's the center O, then this angle here, theta, that is a central angle whose vertex is in the center. And for a 1 radian angle, the arc and the radius are equal. So for example, here's the radius right here. If I said this was 5 and the arc length is 5, then that means that the measure of the angle is 1 radian, because a radian measure is the length of the intercepted arc over the radius, where S is the arc length and R is the radius. So basically it follows that the angle measure would then be S over R in radians. So going back to this picture here, if I said that the arc length was 15 and the radius is 5, then the central angle is going to be 15 over 5, which is 3 radians. So once again, to find the measure of an angle in radians, you just take the arc length and divide it by the radius. And that is the angle measure in radians. And when I say theta, I mean the angle measure in radians. And that's what this means right here. The S stands for arc length, and the R stands for radians. So the next thing we're going to do is we're going to compute some angles using Radian Measure. For example, it says a central angle theta in a circle of radius 12 feet intercepts an arc of length 42 feet. What is the measure in radians? So remember, theta equals arc length over radius. Well, it says the arc length is 42 feet. The radius is 12 feet. If I reduce that, it gives me 7/2, which is the measure in radians. You could say 3.5 if you want, but it's 7/2 radians, or 3.5 radians. Next question. It says a central angle in a circle of radius 6 feet intercepts an arc length of 15 feet. What is the measure in radians? So once again, it's arc length, so 15, over radius, which is 6. So it's 5/2 radians, or if you want to use decimals, it's 2.5 radians. And that's the measure of the angle in radians instead of using degrees. So the next concept we're going to talk about is the relationship between radians and degrees. So basically, we're going to compare the number of degrees and radians in one complete rotation. Well, one complete rotation of the circle is 360 degrees. And remember, when we talk about arc length of a circle, or perimeter, we're talking about circumference. So remember, in radians we talk about arc length over radius. Well, if the arc length of one circle, of the circle, is the circumference, we're talking about 2 pi r over r. And notice the r's cancel out, so it's equal to 2 pi radians. So what this means is that 360 degrees is equal to 2 pi in radians. Which means if you're talking about 1 degree, if we're talking about 1 degree, we just divide by 360. And we get 1 degree equals pi over 180 in radians. Conversely, if we're talking about 360 degrees, 360 degrees equals 2 pi r radians, or sorry, 2 pi radians. And I want to find out how much 1 radian is in degrees. I divide by 2 pi, and I get 180 over pi is equal to 1 radian. So that's how many degrees is in 1 radian, which leads us to our conversion factors. When we convert from degrees to radians, we multiply by pi over 180 in radians. Because notice, 1 radian is equal to 180 over pi degrees. So, but when we convert to radians, notice 1 degree is pi over 180 radians. So when we go from degrees to radians, we multiply by pi over 180. When we go from radians to degrees, we do the opposite. We multiply by 180 over pi, because that's the degrees that 1 radian is. So for example, let's do a couple conversions. The thing asks us to convert 60 degrees to radians. So remember, the rule says whenever we're converting from degrees to radians, we multiply by pi over 180. So we're going to take and multiply by pi over 180, and we're leaving it as fractions. Don't multiply it in your calculator and get a decimal. Leave them as exact answers. So when I multiply these fractions here, notice 60 goes into 180 how many times? If you guess 3, you're right. So it equals pi over 3 in radians. That's your answer. So a 60-degree angle converts to pi over 3 in radians. Going the other way, negative 5 pi over 3 in radians, you want to find out how many degrees that is. Well, remember the rule to convert from radians to degrees is to multiply by 180 over pi. So I multiply it by 180 over pi. And notice the pi's cancel out. And how many times does 3 go into 180? You guessed it, 60. Negative 5 times 60 is negative 300 degrees. So negative 5 pi over 3 in radians is equal to a negative 300 degree angle. That concludes our lesson for today. Hope you have a good weekend, and I will see you guys on Monday.